Hi friends, in previous video we seen that how we can detect the both edges of the input signal and when input signal will change our output become high. Uh, in this video we will see the positive edge detection and negative edge detection. So if you haven't seen that video, please go and watch first part of this video. And this is the circuit which detect the both edges of the input signal, and this is the circuit when input is not synchronized with clock. So we have to add one another D flip flop. You haven't seen the previous video, so please go and watch previous video. After that, come on this video. This is the continuation of the previous video. So moving forward, we see the detection of positive edge and negative edge. So first we will see the positive edge detection. So this is our graph, and this is the output when we have to uh, check for the both edges, but now we have to check only for the positive edge and ignore the negative edges. For that we have to remove this detection. So first we remove this detection and make it continuous. So now we have to trace the waveform and identify which gate have to uh, connect with this circuit here. So input is 0, input is 0, and Q is also 0, so output is 0, and when input is 1, Q is 0 and output is 1, and when input is 1, out Q is 1 and Q bar is 0, uh, so our output is 0. Hmm. And here also when input is 0, Q is 1, Q bar is 0 and output is 0. And in previous cases when input is 1 and output is 0, then Q bar will become 1. So if you consider these two, input and Q bar, we can see that when input is 0 and Q bar is 1, so output is 0, and when input is 1 and Q bar is 1, so output is 1. When input is 1 and Q bar is 0, so output is 0, and when input is 0 and Q bar is 0, then output is 0. It means it is a functionality of AND gate. AND AND gate. See the table, A, B, and Y, 0 0 0 1 1 0 1 1. So in this case 0 0 0 0 1 0 1 0 0 1 1 1. So this is the truth table of AND gate, and the symbol of the AND gate is this one. So we have to add uh, AND gate here as an output detection, but before that we have to make Q to Q bar. For that we have to add one inverter, so we will add one inverter here and connect a AND gate, and this will be the output. So by connecting this combination, we can detect only positive edge and it will ignore the negative edge. And if I talk about the negative edge detection, negative edge detection. mm, Before that, if our input is not synchronized, means if our input is this input is not synchronized with clock, means it not come after the clock. So we have to add one more D flip flop for synchronize it, and the same circuit have to connect for the positive edge detection. How this D flip flop have to add, and what will be the effect, you can see in previous video. There I explained everything, and in this video we only see the positive edge detection and negative edge detection. The positive edge detection completed. Now going forward to the negative edge detection. So for the negative edge detection, if you talk the second graph, uh, and this is the same graph of this, but if you if you see, when input is 0, input is 0, q is 0, input is 1, q is 0, and input bar is 1 0, and input is 1, q is 1, and input bar become 0. And when input is 0, q is 1, and input bar is 1, and so it is 1. So for the negative detection, we have to detect only negative edge. We have to ignore this one, positive edge. We have to detect only negative edge. So for that, first we have to remove this graph, and we have to detect only this part. So when input is 0, q is 1, and input bar is 1, and when input is 0, q is 0, input bar is 1, and our output becomes 0. And we can see only the condition when our q is 1 and the input bar is 1. At that time only our input is output is 1. Other rest of the condition, we can see that our output is 0 0. So for that case, uh, we use same AND gate, but in this case we have to invert the input. In previous case we inverted the q, you can see q to q bar. In this case we invert the input should be inverted to input bar. So for that we only change the inverter position. So we change the inverter position. We connect one inverter with the input, that will invert the input as input bar, input bar, and everything will be same. So this circuit is, when input is not synchronized with clock, means input is not come after the clock. So we use one D flip flop that will synchronize our input with the clock. You can see in previous video I explained very well in that video. So I think you understand the condition when we have when we have to add inverter with the Q, and use the AND gate for the positive edge detection, and when we have to use inverter in input uh, and followed by we have to add AND gate for detection of negative edge here. I think you understand very well. Thank you.